In this lesson, we're going to talk about the power of powers property.
Unless you've got power!
What? Who said math wasn't interesting? Alright, so the rule for the power of powers rule is that anything a to the m raised to the n, we've got a power on top of a power. What we do is we have a to the m times n. So let's look at an example. If we have x squared to the third power, we really have x to the 2 times 3 power, times, and so we have x to the 6th power. This next example might not look like a power of power property, but let's say we wanted to reduce the base from 8 down to 2. 8 can be rewritten as 2 to the third, and now it's still to the third power, so we've really got 2 to the 3 times 3, or to the 9th power. This property also has implications for when we have a product inside parentheses. So if we have something like a to the h, b to the k, all to the m will distribute to the powers and all the factors inside the parentheses. So this would become a to the m times h, b to the m times k. So let's look at the example below. If we have x to the fourth, y to the negative fifth in parentheses, all raised to the third, that 3 is going to distribute, and when it does so, it's going to multiply by those exponents. We're going to get x to the 12, y to the negative 15. Of course, we don't want to leave any negative exponents in our final answer, so we're going to rewrite that as x to the 12th, and this y to the negative 15th is going to move to the bottom and become y to the positive 15th. So that's your final answer. When we have a quotient in parentheses, the power of powers rule also applies, and we distribute this m to the powers of both the numerator and denominator. So if we have a to the h over b to the k raised to the m, we have a to the m h over b to the m k. So in the example below, we're going to take this 2 and distribute it to the 4. But we're also going to distribute to the 2. Remember, the 2 currently has an exponent of 1, and it is a separate factor. The 2 and the x are not combined. They are separated by a multiplication sign there. And then finally, to the y to the negative third. So it's going to become 2 to the second, because 1 times 2 is 2, x to the 8 over y to the negative 6. We're going to take this and simplify a little further, because we have a negative exponent, and we can work with that coefficient. So we're going to make this 4x to the 8th, and the y to the negative 6 is going to come up top as a y to the positive 6, and that's our final answer. A couple more examples. 2 times x squared to the times y to the negative third, all squared. Let's distribute that exponent, and we get 2 squared, x to the fourth, y to the negative 6. I know I'm going to have a fraction here, so I'm going to draw my fraction line. 2 to the second is 4. X to the fourth stays the same, and this y to the 6 is going to move to the bottom as y to the positive 6, and that's our final answer there. This next example looks terrible, but if we notice, everything is raised to the 0 power, and if we multiply all those exponents by 0, they'll all become 0, and anything with a 0 exponent is simply 1. So that's our final answer. This example isn't so nice and easy, but let's dive into it. So we're going to distribute our negative 3 exponent on the outside to everything. But wait, that looks pretty complicated. Instead of doing that as our first step, let's go ahead and actually simplify anything we can inside first. So I'm going to work inside the parentheses. I can't do anything with the 2/3. I see an x to the negative 2 here. I'm going to bring that up. And I'm going to have x to the second and x to the fourth that was already there. I see this y to the negative 1 here. I'm going to bring that down. So I'm going to have y to the first and y to the 8th, and now I've still got this negative third power. Continuing to work inside, I'm going to have a 2 over 3 x to the 6th by adding them with the product rule, and y to the 7th, now all to the negative third power. A little less complicated. Now I'm going to distribute that negative 3 exponent on the outside of the parentheses to everything inside. So I'm going to get 2 to the negative 3, x to the negative 18, all over 3 to the negative 3, y to the negative 21st. Look, everything happens to be a negative power now, so we're going to move those, and in fact everything's going to flip sides. So we got 3 to the 3rd, y to the 21st moving to the top, over 2 to the 3rd, x to the 18th on the bottom. We could take this a little further and do 3 to the 3rd and get 27, y to the 21st, over 8x to the 18th. And that's our final answer. No negative exponents. We only have one y, we only have one x. That tells us we're done.